Hello, everyone. Uh, Please come closer if you need. The place is really noisy. If at any time during the talk you need to see the slide better, just move. That's okay for me. So today we are going to talk about accessibility again, but not the usual stuff like how or when to put a content description. We are going to go deeper and to talk about how to improve the navigation of users using screen readers. And to make it a little bit more fun, you are going to compete each other in an interactive quiz about accessibility. So let's start to set up everything for the quiz. You can all join the quiz like this. So go to menti.com or scan the QR code and enter the code. I'll wait a few seconds to see. So you're going to compete in 8 questions. Every 5 minutes in the talk, I will stop to query you about accessibility. Some questions you will get more points if you're faster. Some just regular question, no more points if you are faster than your neighbor. Okay. Can I start? Yeah? We'll start with an easy question just to warm you up. So all answers give maximum point. What is the shortened form for accessibility? It takes 4 characters. Three, two, one. And the correct answer is A11Y. A for the first letter, Y for the last letter, and 11 letter between A and Y for accessibility. So you see, every time you will see the leaderboard, and for now, lots of people have the same amount of points. Okay, let's move back to the slides. First, let's introduce accessibility by speaking about disabilities. And I want to share with you some statistics to introduce it. There are 1.3 billion of people with a disability in the world, according to the World Health Organization statistics. If we zoom a little bit where we are, so first in Europe, there are 135 million of people with disabilities. At the world stage, it makes about 17% of people with disabilities. And even if we zoom to Europe, there are still like 18% with a disability. And if we zoom again in the UK, 16 million of people have a disability. That makes again the same proportion, about 16% of the population. And with the aging population, this is going to increase. Okay, let's recap. What are the different types of disability? First type of disability is motor disability. For example, people who have issue with hands, with legs, people who cannot stand up for a long time. And us, as mobile developers, we will be concerned by people, of course, that are not able to use their hands normally. Second type of disability is auditory. It's concerned all people having hearing issue. That's the biggest type of disability. In the UK, there are 11 million of persons with hearing issue. 16 million, it's a lot. Next category is cognitive disabilities. It's really a wide type of disabilities, going from dyslexia, autism, Alzheimer's disease, and people having difficulties to focus and so on. Again, it's a big category, 1 million of people with cognitive disabilities. And the last one is visual disability. It concerns people who are blind or with low vision. There are about 2 million of persons in the UK with this kind of disability. Among them, 500,000 are blind. Which leads me to the next question. Yep. Answer fast and you get more points for this question. As developers, on which type of disability do we have a direct impact? Is it visual? Is it cognitive? Is it motor? Or is it hearing disability? I hear, oh. And yes, there are actually two good answers, visual and motor disabilities. Let's look at the leaderboard. Well done, Alain. Where is Alain? Well done. Okay. So visual and motor disability. Why? First, let's see why not cognitive and auditory disability. People with cognitive disability have common issues: difficulties to focus, difficulties to memorize, or difficulty with the language. If the language is difficult or is dense, it's harder for them to understand the content. And all the best practices to help them is UI and UX best practices. So as developer, we are not going to design the features that suit them best. It's the designer or the product manager doing that. Of course, we are implementing that, but we are not the starting point. Regarding auditory disability, in our apps, every time a content is audio content, like a video or just audio, if we don't provide alternative way to get this information, well, they will not get the information. So basically, that means adding a transcription, adding a caption, adding a features that helps the user to add himself or herself a description for a social application, for example. And again, as developer, it's not us who is going to change the UI, change the feature to adapt to this disability. Okay, people with visual disability, they use a lot of different tools already installed on your Android phone. There are things that help you magnify the screen, there are things that help you change the font size, and there is also Talkback, the screen reader used by blind users. And when you have a motor disability, again, you might be using what we call clickers that will enable you also to navigate through the screen with another part of your body, for example, your legs, your mouth, your eyes, your everything. And all those tools, they all plug to the same things on your Android phone. It's switch access. And switch access and Talkback, they use behind the same API. So basically, as a developer, when you make your application usable for a screen reader, it will be usable for someone with a motor issue. And it is our responsibility to be compliant with how they work and that our application works for them too. It's not the designer who is going to say us, okay, improve the navigation or do things like that. So today we are going to focus on screen reader specific user experience to understand how users navigate through our apps and how we can improve that. And we are going through two best practices. The first one is how we can optimize the reading order of elements on the screen. And the second one is how to facilitate navigation. Optimize reading order. Which leads me to the third question. If it's okay. No, don't do that. Yeah. So, by default, in a native application, in which order a screen reader browses elements on the screen? Is it based on the position of elements in the view hierarchy? For example, in the position of one element in your XML or in your compose and semantic trees? Or is it based on the element's position on the screen? Oh, we don't see the answer? So the answer is that it is based on the position of the element on the screen. And it can be confusing because on the web, with the DOM, it's the opposite. It's based on the position of element in the view hierarchy. So on a web application, if you want one element to be read before, you just move it higher in the hierarchy in your HTML. But on Android and iOS in native application, it's the position on the screen. And a screen reader, we go through each element on the screen one by one, starting from the top left to the bottom right. So in which situation the default reading order could be an issue? Then I see two issues, two cases. First scenario is when elements are displayed in a way that reading them in this order doesn't make sense. And the official documentation of Jetpack Compose for accessibility illustrates it really well. You see here the component with the time. If we read the content by this logic, it will say 12, then 11, 1, 10, 2, 9, 3, 8, 4, 7, 5, 6. That doesn't make sense. It should be 12, 1, 2, 3, 4, 5, 6, all the way through the wheel. The second issue that we are going to go dive today in the talk is sometimes navigating to the main action, the main information of a screen can take a while. Which leads me to a new question for you. Ooh. With Tollback, do you know what gesture allows you to navigate between elements? So for example, here, how to navigate from text 1 to text 2. Is it swipe up or down anywhere on your screen, or is it swipe left or right anywhere on the screen? Oh, I'm always missing the answer. It's okay. So the answer is swiping right and left, and it will move the focus between each element. I will illustrate it here. So by swiping right, the focus moves to text 2. And the swipe right can be performed anywhere on the screen, and the focus will be moved. And of course, Tollback, the phone, will announce text 1, text 2. So let's go back to our use case. In which situation reading order could be an issue? Well, if we take Spotify, for example, the main feature of this screen is playing and pausing the music. Let's see how many gestures it takes to go through this button. First, it goes through playing from playlist Summer 21. Second, to this button. Then they did it well. They didn't put any content description, so the image is ignored, and it moves to the text of the title of the music. It moves then to the like button, then to the slider, then to the shuffle button, then to the go back button, and finally on the play button. It took us 8 gestures to reach the main feature of this screen. So what can we do? First, we can modify the reading order. And then we will see that we can also add another element higher in the hierarchy that is unable to perform the same action or is giving the same information. Let's see how. First, how to modify the reading order. Since Jetpack Compose 1.5, we are finally able to do that with Compose. We were able to do that with XML, with traversal index before and after, two properties in XML. So now we can do that by using the modifier.semantics and changing the values of traversal index and setting 1, 2, 3, and so on. Which leads me to a new question. Oh. Okay. What is the reading order of this screen? Is it text 1, swipe right, text 3, swipe right, text 2? Or is it text 2, then text 3, then text 1? And the answer is text 1, text 3, and text 2. Let's move back to the code to see it again. Dan is going to do pretty well. Who is Dan? Well done. So, yes, first text 1 with the number 1, then text 3 with the number 2, and then text 2 with the number 3. If we put no traversal index, it's actually traversal index, the default value is 0. So we could have set no traversal index to text 1 and it would still have been read first. We can also put a negative value. And we can also add this information on the parents to make sure that this ponderation will not be will not take into account the other element on the screen, but also have traversal index 0, for example. So this sorting is only applying to this element. Be careful, if you are also developing on iOS, there is the same modifier doing almost the same, accessibility sort priority, but it's the opposite. The first element that will be read as the number 3, then 2, then 1. So always test, because I'm always forgetting which ones to use. OK, let's see now how adding another element higher in the view hierarchy can be done and how it can be helpful. We are going to do that if we detect that the screen reader is active. It's not necessary to put, for example, in Spotify, another play button higher in the hierarchy for everyone. So you can see also a really good example on the Gmail application. If you start Gmail with a screen reader activated, then there will be a write new email button that appears in the navigation bar. And to do that, it just takes 2 lines of code. You take reference to the accessibility manager, and you have these 2 Boolean values. The first one, check if the user already enabled accessibility service in his phone. Basically, if he or she ever has been to the accessibility settings of the phone. And the second Boolean value is touch exploration enabled. Then you use this Boolean and you just add a button on your screen. OK, we have seen now how to optimize reading order. Let's see how we can facilitate navigation. First, let's recap what are the main navigation gestures with Talkback. The first one is double tap to activate. Anytime a button or an element has an action behind, like a click, well, the screen reader will announce double tap to activate. So you double tap anywhere on the screen, and it will perform the click. Swipe right and left with that gesture. Single tap. If you single tap on one element, one specific element on the screen, it will move the focus to that element. which is useful as developer, but also blind people tend to use this kind of gesture when they know the position of one element, and this element is easily reachable regarding the phone. For example, bottom menu, or if you have an element which is always on the bottom left or just behind the screen. And then there is one last gesture, swipe up, swipe down, which is normally and usually a gesture that you can configure. To configure the behavior behind this gesture, you perform a V or a V this way or this way. And it will move the action of this button. For example, it can be going one character per character. It can be changing the speed of how fast is picking talkback, or it can be moving between headings. And which leads me to the first best practice to optimize the navigation is using headings. And then we will see how to reduce the number of gestures. To use headings, for example, let's take Spotify again. And here, Spotify, they've done things right. When I use it with talkback and I'm on this title, it says Story for Kids, headings. And as a screen reader user, as I hear headings, I know that if I swipe down, it will move to the next heading on the screen. So I swipe down, and it moves to recently played, which has been marked also as a heading. To do that, it's really simple. You just, again, use the modifier.semantics, and inside you call the function heading. Now let's see how to reduce the number of gestures to navigate one component. And I would like to propose you this use case is the Twitter application. Sorry, I still say Twitter. And that leads me to my next question. In your opinion, yes, how many gestures are necessary to go through one tweet with the actual Twitter application, knowing that they have done things right? Let's start again the question. So how many gestures are required to navigate through one tweet with the actual Twitter application? And the answer is just one. I don't see your answer, but who did well? Oh, okay. Oh. So how can we do that? And how they do that? First, they use two best practices. The first one is merge related components. And the second one is use specific interaction available on screen reader. So merge related components to make sure that the tweet is just one focused and that it's going to read all the elements on one tweet. It's easy. We again use the modifier.semantics and set the merge descendant parameter to true. And it will just merge all the content description of its child and announce them one by one with only one gesture. Now, how to use specific interaction available on the screen. There are two specific interactions that exist, which are custom action and long click. Let's see how custom actions work. When I'm on a tweet, it says double tap to view full comment session. It's the normal click action. And it also says actions available. Use tap with 3 fingers to view. And if I tap with 3 fingers, a new menu opens on the screen, and the focus goes through the first action, activate to view post detail. Then I can swipe right, and it will move to reply. There is also another way to access custom action. If the user has set up the swipe up, swipe down gesture to actions, well, when the user is on a tweet, he can swipe up or swipe down, and it will swipe between the different actions, like reply or retweet and so on. So to do that with Compose, again, it's pretty easy. We set the value of custom action, which takes a list of custom accessibility action. We can customize the label, so saying reply, and then in action we put the action behind, and that's it. It's also available if you're still using XML. Now let's see how to perform a long click, which leads me to another question. Do you know how to perform a long click with talkback? Is it tap 1 time and hold, a long click? Is it tap 2 times and hold? Is it tap 1 time with 2 fingers? Is it tap 3 times? So much suspense. And yes, the answer is tap 2 times and hold. Let's see the leaderboard. So it's actually a talkback says double tap and hold. So if we go back to our tweet, it will say double tap and hold to interact with this tweet. We tap once, and the second tap will remain the finger on the screen. And then a menu appears, which helps us access again, reply, repost, like, and share. You might wonder, we already have those actions in the custom actions. Well, a good practice also in accessibility is to provide different way to a user to access a content, whatever, if with a screen reader or not with a screen reader. That's the best practice, to let the user choose the more convenient way for him or her to access a content. So again, adding a long click, it's like a usual long click. What's interesting here is that the user hears that on this button or on this component, there is a long click. He can long click. If you are not using a screen reader, you don't know when you can perform a long click on some button. Sometimes I discover features in app like years after, you can long click and it doesn't do like, it does a thumb. Oh, but how do you know that? And I think it's great that people with using screen reader, they just know it by default because it's announced. The last 2D case I want to tell you today, it's what I've called the Netflix pattern. Let me explain it to you. You might know that navigating between items in a list can be really difficult sometimes, especially with this kind of layout, when you have lots of horizontal lists, and sometimes they are really, really big lists. And if you're using a screen reader, let's say I'm on this movie, and with an E, I swipe right, it moves to How to Get Away with Murders. I swipe right, and again, and again, and it can take long. And if I decide that finally I'm not interested in this category of movies, I can go out, because I'm not on the heading anymore, so I cannot use the heading feature to move to the other component. And we see this kind of layouts in many of our media applications. Which leads me to the last question. Boop, boop, boop. Which material component could be tricked to improve the navigation in an horizontal list, what I've called the Netflix pattern? I found a solution that we could use to improve this scenario. Is it by using a slider? Is it by using a switch? Is it by using a progress indicator component? Go, go, go. And yes, if you trick the slider component, you can improve this behavior. Let's see how. Well, the specificity of the slider component is that it's the only component that, to interact with it, you swipe up or down. Whatever the setting of your swipe up, swipe down gesture, if you're on a slider, if you want to increase the value, you swipe up. You want to decrease the value, you swipe down. So let's imagine our whole list is just a big slider. And the first movie is the 0 value of our slider. I swipe down, then it will move to the next value of the slider, how to get away with murder. Then I can swipe down again to move to the next element. The good thing is, if at one point I want to move to Emmy-winning TV comedies, then I swipe right. And I'm out of the trap. To do that on Android, that's quite painful for the moment, because sliders can only contain digital value, and here we want to contain movies, titles, and so on. And controlling its value is also kind of painful. But it's not on iOS. And I'm going to show you the API with SwiftUI, and after I will show you the feature request I asked for Jetpack Compose team. So with SwiftUI, on any component, you can add the modifier accessibility adjustable action, and it gives you a lambda with as an input the direction, and regarding the direction, you get increment or decrement. Increment is swipe up, decrement is swipe down. And you do whatever you want with the value. It's completely stateless. The slider on Android is still quite stateful. I managed to do that on an application I'm working on, but I'm not going to show you the code because it's really ugly, and I had to copy past an internal function from the source code of Compose, which is a shame. But I'm going to show you what I think could be a good implementation for us to add a slider semantic to any component. We will have, for example, a slider semantic actions modifier with 2 lambdas, increment and decrement. And then inside, for example, we can change the value of a state that we have, increase it or decrease it, and even better, increment a loop when we are at the end, then go back to the first element. Or we could also announce you are at the end of the list. And I'm not inventing this behavior. I'm actually working for the Valentin Ahui Foundation. It's the biggest foundation for blind and low vision users, persons in France. And they actually asked me to implement this feature on a player we are doing. So for example, we implemented it on the features to go back from 30 minutes, and they actually can change the value from 5 minutes, 30 seconds, by using a slider for this feature. So really, I'm not inventing it. They asked me to do that. They actually saw this in an application called Orange in France, which is a TV and internet provider which is doing lots of things about accessibility. So let's do a quick recap. Yeah. We've seen some best practice. The first one, optimize the reading order. the second one, facilitate the navigation. To optimize the reading order, we have to modify we can modify the reading order, or we can add a second element higher in the hierarchy if a screen reader is active. To facilitate navigation, we can use headings, or we can also reduce the number of gestures by merging components or using specific interaction like long click and custom actions. Okay, now I guess you want to know who is the winner of this sweet surprise I bring from north of France. These are waffles, like you can see here on the pictures. It's really typical from where I come from, Lille. Okay, who is going to win? This is the answer from the previous question, I guess. But suspense. No, there is no suspense. Enter to show winner. Oh, who are there? Okay, I go back to the previous screen. Who is the winner? I think it's Arc, right? Oh, maybe not. No, it's Dan. Dan, it's you. No? Yeah. No, it's not you. Who is Dan? Who is Dan? Oh, yeah, it's you. Welcome. You can come after to take the waffles. Okay, so thank you for listening to me.